Hello, very warm welcome. So today we are looking at another LeetCode question, which is shortest path in binary matrix. What this question says is we are given a 2D matrix, and in this it contains only binary values. Now what we need to do is we need to kind of traverse through all zeros in that particular matrix, and then see that okay, if I move from the 0 comma 0 or in the starting to the very end, if do I have a path or path present or not. So and you can move up, up, left, right, top, diagonal, whichever way you want. This is very similar to kind of questions which you generally have in which you kind of you would have solved in various puzzles wherein you try to kind of find a path from A to B, where in this place my A is this one and my B is this one, right? Irrespective of which kind of matrix it is, even if it is a big one, all you need to do find is a path from this place to this place. This is what we need to do, right? Now, how to approach this problem? If you see, right, at whenever we are traversing through, first of all, let's talk about bounding conditions, right? I should always have a zero at the position A, which I just talked about, and position B, which I just talked about, right? Because A and B are like source and the destination. I should always have a 0 and 0. Now, if and then what I need to do is, right, let me put it in a so if I'm using say this matrix, right, which is say 4 comma 4 or 4 comma 3, right? So this contains 0 1 1 0 1 0 0 0 1 1 1, or say make it 0, make it 0, make it 0, right? So what we need to do is we'll say okay, we'll have a pointer at this place. Say I'm at this place, right? So when I'm at this place, I'll say okay, I'll see what are the neighbors of it. I have these three as the neighbors of it, right? When I have these three of neighbor of it, which one is the one which I can traverse through? I can traverse through this one. So I'll mark them as visible. I have already covered this path, right? And that's where the job of this particular, you can say, index is done. It has kind of found out all the neighbors, and if I put it in a data structure, it will put everything into a data structure called queue. Because what we're trying to do is, if you see, we are looking at all the neighbors of it. So it's in a way you're doing a breadth first search here, where you're at a given node, you're looking at all the neighbors of it, right? So when I'm at 0, I'll see all the neighbors of it, which is 1 0 1, right? Which one of them is I can traverse through? It will be 0. But before going there, I'll just say okay, my job of this button is done, this particular index is done. I'll now move to the next iteration. I'll say I'll then go ahead and iterate through all these 1 0 and 1. I'll see which one is the one which I can really use right now. I can use 0, right? The moment I can use 0, I'll see what all the neighbors of 0 which are not visited. So these are already visited. The moment I kind of traverse them, these are visited. Okay, when I'm at this one, I'll say okay, the neighbor of this, because we're looking diagonal, this is something which I can use, 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 and this is also something which I can use, right? So the job of this particular iteration is done. It kind of found all the neighbors and put it into the queue. Now my next job is to find out, go through this particular third iteration, right? Then I'll go ahead and use go ahead and kind of traverse through all these ones, and then I'll see okay, what are the neighbors of that one. That will be say this one, this one, this one. The moment I find an a zero which is of your B, in the sense your destination index, right? Then and there I'll return okay, I got the path. So in this place, right, if you see what we tried to do is we didn't try to go and find okay, what are the paths. We didn't went and try to find out okay, this is one path, right? We didn't try to find out this is one path, right? We didn't went and find out this is also one path, right? What we said is if I'm at this place, find the neighbors, work on those neighbors, find their neighbors, whatever neighbors I just got, find their neighbors, And by chance, the moment you hit 0, right, that is your, you can say, the minimum number of steps which were needed to reach from source to the destination. Because in this place, this one this one iteration which I'm doing here, is one step, right? So I was at this step, this was step 1, this was step 2, this was third step, this was fourth step, right? So this is how we are going to approach this problem, because if you see the shortest path, that will be this one. This is fourth step, right? This is your shortest path, right? Let me change the color. So this is your shortest path, because this was 0, this was 0, this was 0, and this was 0, right? This is a short process, and hence the output will be 4, because see, we did 4 steps, right? So I hope you would have understood the approach. Let's quickly jump onto the code and see what needs to be done. So what we'll do is we'll create rows first, do the boundary stuff first. That will be my grid dot length, and my int call is equal to grid 0 dot length, right? I got rows and columns. Then I'll see, okay, if my source and destination are zeros or not. If they are not, then I'll just return -1, because there is no path to reach the uh, end goal. Is double equal to 0, is not equal to 0, or say make it 1, because it's like it's anyways containing binary values. Or my grid row -1 and call -1 is double equal to 1, right? Then I'll say return -1. So my boundary conditions are done. Now what I'll do is I'll create a queue. So that will be, say, queue. Now, if you see this, right, I'm going to, in this queue, I'm going to store the positions of I and j. That means the index of I and j. That will be I comma j. So that let's make it int comma int, right? My queue is equal to new queue int comma int, right? Now my queue is ready. Now next few things which we need to do is we need to also keep a tab of whether I given row is visited or not. Because if you see, if it's already visited, I don't need to visit it again. So I'll create a bool that will again be int comma int type, and it will say visited. So that will be new bool rows comma columns. Right, my visited array is also ready. Now another thing is what I need to return is the steps, right? Return the steps, whichever is the steps I got. So initially I'll make it 0. Int steps is equal to 0. Now I think another thing which we'll need is the directions in which I need to go. Because if you see, I have to go in all the 4 directions, right? So that will be up, left, bottom, right. So if in a given matrix, if I look at this matrix, right? Say I'm at this place, right? This is 0 comma 0, this is 0 comma 1, this is 1 comma 0, 1 comma 1, and this is 1 comma 0. So if I'm at this position, this is, in order to go to this place, I need to add 0 comma 1, 0 to the x-axis and 1 to the y-axis. Then in this place, if I have to go to this position, I need to add 1 to the x and 0 to the y. And if I'm going to this action, I need to add 1 1 both to this particular value, right? So with that explanation, let's go ahead and create the directions. So where all directions I can go with. So that will be new int. So I and j, let's make it like this, and that will be something like this. So that will be 0 comma 1. So that will be 0 comma 1, 0 comma -1, 1 comma 0, -1 comma 0, and so on and so. This is like if I'm at given index, I need to add 0 comma I need to add 1 to the y-axis, 1 to the x-axis, -1 from the y and x-axis, and so and so, because at a given position I have to go in all the 4 directions, all the 6 directions. This is how it has to go, all the directions, right? So if I'm at 2 comma 2, I have to go to 1 comma 1, 1 comma 2, 1 comma 1 comma 1 comma 1, 1 comma 2, 1 comma 1, 2 comma 1, 2, 3 comma 2, 3 comma 3, 3 comma 2 comma 3, and 1 comma 3. So we have to go in all the directions. So I have my directions ready now. So what I need to do now is I'll start with the 0th index, right? So first of all, I'll add that to the queue. My queue dot enqueue 0 comma 0, right? That will be 0 comma 0. That is my first index when I'm going to go ahead and work on this grid, right? And then I'm going to say, okay, this is visited for me right now. This 0 comma 0 is visited for me right now. And what I'll say is I'll run this 3. So if you see, right, whenever you're going to work on the breadth first search approaches, you'll generally work through the entire queue until unless you are kind of into that until unless we have a value into that queue or not, right? And every time you work through into that queue, you kind of dequeue that particular index, do the set of operations, and in this place I need to kind of dequeue it, find all neighbors, add it to the queue, and then keep on repeating the steps, right? So for me, I'll say, okay, while my queue is having a value, then what I'll say is I'll get the size of my queue dot count. What I say is, okay, I'll go and iterate. So this is what I just said, right? We'll have to go ahead and assume that whatever I have in the queue at that time is going to be one step, right? That will be I less than size, I plus plus, and I'll go ahead and look for my current index. So what my current index is, current index, that will be your my queue dot dq, because I stored 0 comma 0 there if you see in the first code, right? Then I'll say, okay, if then I'll look for whether this current index is the destination or not. If it's a destination, then I'm good, right? So current index dot item 1, which will contain your x-axis value, is double equal to row minus 1, and current index dot item 2 is double equal to call minus 1. If it is true, then I'll just return whatever my steps were, steps plus 1, right? Now what I'll say is, okay, if it is not my destination, right, then I'll go ahead and look for all the directions. So I'll go ahead and look for all the directions. So that will be int d is equal to 0, d is less than directions dot length, or d plus plus, and I'll say what is my next x and next y will be int next x, x, that will be current index dot item 1 plus directions d 0, that will be my 0th in this because I'm using item 1, and my next y will be item 2, item 2, right? Now I have my next x and next y. Now what I'll do is I'll see whether these are inside the set of conditions which you're going to have. What are the set of conditions? That should not be greater than my grid length, right? That should not be greater than that grid length. That should not be less than 0. That should have a value of 0, and that is no longer not yet visited, right? So next y is greater than equal to 0, right? Now it should not be greater than your length of the array. So next x is not should be less than, that means my row, right? And it should be next y should be less than my call, and let me get it, and it is no longer visited, it is yet not visited next x, comma next y is not yet visited, and whatever my grid next x next y is, that should be equal to 0. That means I can visit it. Then only I'll go ahead and add it to the queue. I hope you understood this step. This is just the boundary conditions which we generally have whenever we are trying to look for all the neighbors. In this case, we need to ensure that okay, whatever we are going to next with, that is following in within the grid itself. Right. So I'll say my queue dot enqueue next x comma next y, and I'll mark them as visited. Visited next x comma next y is equal to true. Right. So once I am done with, so this is like, if you see, right, I went through my queue first 0 comma 0. Now in that 0 comma 0 I kind of dequeued it, that size was 1, and then I found all the neighbors, right, and added to the queue. Right. Once I'm done with addition of the queue, right, I will not, if in case I found the destination, then well and good. If not, then I'll go ahead and try this step again and move out of that index. 0 comma 0 will have, will this will run only once, and it will find three neighbors. So if I look at the example, if I'm at this position, so if I am at this position, it will find three neighbors. This will be this one. Now I complete this step at this place. Now I'll work on this step, right? So I'll say the moment my whole the moment I'm done with finding all the neighbors, I'll say my steps plus plus, right? In case haven't found anything, I'll return -1, right? Because if you see, why I did step +1 here is because, say I was at this place, right? I found all the neighbors. I found all the neighbors. These are this one. The moment I'm iterating through this one, right? I will find, the moment I'm trying to find the neighbor, I will get this value as well, right? So I was done with two steps, right? I was done with this one. I was done with this one. So I don't need to iterate the third step because I already found the destination with 0 comma 0. I'll just do 2 plus 1, return it, right? So this is it. I think this is the fair way kind of in which we can solve this problem. Let's run this and see if everything is working fine. Okay, I got the first error, which is at line number 16. Okay, shoot. The rows and columns. Okay, I made it row and column, so let that be row col. Let's run it again. Okay, it got accepted for 0 0. I have steps 2. Let's submit it. It got accepted faster than 95%. Cool. So I hope you would have understood the explanation. In case you still have any doubts, any confusion, anything of that sort, please do reach out in the comment section. I'll be more than glad to help. Uh, just again to kind of weigh out the thought process, whenever we are looking at a question which talks about the path, looks for the shortest path, I think you can directly go to DFS and BFS. Generally when you're working on the BFS is when you kind of use queues, because that's time you kind of look at all the neighbors, add it to the queue, and then work on that queue, right? So and in order to find the neighbors, you generally have the directions. It may or may not have the diagonal associated to it. Generally it has like top down bottom left. Diagonals are not part of it, but if they're part of it, then accordingly you need to kind of add those indexes, because that's where, if you see, 1 comma 1 got added because I need to go ahead and look for the next diagonal value, which is downwards. This is it, guys. Thank you, thanks a lot. In case you like this explanation, please do hit on the like button. If you are new to the channel, then please do subscribe. uh, Thank you, thanks a lot.